Let me explain the bullet you see in my profile that reads Concept to Implementation, ASIC Thermal Monitoring System in Real Time. As a test engineer in Arista's Logic, I was challenged to develop a subsystem that monitored the die temperature of our ASIC in real time. Our ASIC and most ASICs of today have embedded diodes, and they are called many terms, but I call them substrate thermal diodes. Our ASIC had one of them, so I decided to take advantage of its existence. In our lab, I needed a development platform. I found that we had FC link breaker boards lying around the lab that were not used anymore. So I decided to make use of them. Although it had a PIC micro as its processor, an 8-bit PIC micro, I knew it could be a problem because a PIC micro didn't have I2C capable hardware embedded in it. That's okay, I said to myself. I could always emulate I2C functions in my software routines. So here's how I envisioned how it would work. I chose a thermal sensor MAX 6657 made by Maxine. The decision to use a Maxine 665 sensor thermal temperature sensor is because it had 11-bit resolution, and the specs claim that no calibration is required. And after checking our bill of materials in our lab, we already had a part in our system. Moving on to the other pages, on table 2 seems very reasonable. 130 degrees is the max, and it goes all the way to negative 55 degrees. A pretty impressive temperature range, I would think. Although I would have to deal with a 2-complement data format, I can always deal with that in my software. So let us use it. In my mind, I would have this configuration. I would have a PIC micro feeding its I2C signals to the temperature sensor, and the MAX 6657 would have 2 leads wired to the substrate diode on the ASIC, which, by the way, is external to the platform. This is the platform wherein we have the temperature sensor kludged upside down on the board. We call that as a dead bug kludge. We have the PIC micro here, and let's have a closer look. Here it is. We have the temperature sensor. We have the clock signals and the data signals coming off to an external port here, so I can monitor it with a scope. Then to emulate the diode embedded in the ASIC, I have a PN junction hanging out here. So now that my hardware is done, all I have to do is to develop software. After developing software, I showed it to my superiors, and months later, when the next generation ASIC validation board came around, it was actually designed into that board. So here is the schematic of the next generation validation board. They incorporated my PIC micro. They also had a programming port, so I could change my firmware on the fly. I asked them to put a serial port header, so that's where I would output my data. And here we have our MAX 6657 with the I2C signals coming in to the PIC micro. Then we have the two lines going to the ASIC, wherein the embedded substrate diode is. Finished product is here. It's called the MPX validation board. You can see the Maxim 6657 here. You can see the PIC 8-bit microcontroller. And this header right here goes to the serial port right here. As the temperature of the ASIC goes up, my software tracks it at 43.8, 45, 47, and it goes on. So we had about 50 or 55 MPX validation boards throughout our company, and all of these had my routines and had my LCD on the test bench. Thank you for listening.